This is Physics Chapter 12, Problem 88, and it reads, a 5-meter diameter garden pond holds 5.9 times 10 to the third kilograms of water. 400 watts per meter squared of solar energy strikes the pond surface, meaning each square meter of the pond surface is absorbing 400 watts. How many hours will it take for the pond to warm from 15 degrees Celsius to 25 degrees Celsius? So, to start this, I'm just going to write down all the values we have. So we have the diameter of the pond was 5 meters. So that means the radius is 2.5 meters. And then the intensity was the 400 watts per meter squared. And then the equation that we are going to use is Q is equal to M multiplied by specific heat multiplied by the change in temperature. But to do that, we need to convert our degrees Celsius to Kelvin. So once we do that, we had 15 degrees Celsius and 25 degrees Celsius. And once you convert those, they become 298 Kelvin and 288 Kelvin. So now we can plug those into this. So we get Q is equal to our mass, which was given as 5.9 times 10 to the third kilograms of the pond, multiplied by the specific heat of water, which is 4,190 joules per kilogram per Kelvin. And then our change in temperature is 298 Kelvin, subtract 288 Kelvin. And we end up getting 2.47 times 10 to the 8 joules. And then our thermal conductivity equation is H is equal to intensity multiplied by A. And our intensity was 400 watts per meter squared. And A is equal to pi multiplied by the radius squared. So we end up getting 400 watts per meter squared multiplied by pi multiplied by 2.5 meters squared. We get 7,850 watts. And then another thermal conductivity equation is H is equal to Q over T. And our Q we solved for up there was 2.47 times 10 to the 8 joules. And then, so we can plug that in, and then T over T. We need to rearrange this equation and solve for T because we're looking for the time that it takes. So we get T is equal to 2.47 times 10 to the 8 joules, which was our Q, over our H, which we just solved for there, which is 7,850 watts. And we end up getting 0.3146 times 10 to the 5th seconds. And we need to convert that into hours because that's what the problem asks for. So we take 0.3146 times 10 to the 5th seconds. And in 1 hour, there's 3,600 seconds. So we divide that, and we end up getting 8.73 hours.